Imagine it's next Tuesday. You wake up, and your phone has already read your overnight emails.
Right, it saw your flight was canceled.
Exactly. They realized the flight was canceled, negotiated a refund with the airline's automated system, and rebooked you on a better route.
All before you've even poured your first cup of coffee.
Yeah, and that level of automation, I mean, it's really no longer science fiction.
No, it's not. It is pretty much here.
Because between March 15th and March 21st, 2026, the artificial intelligence landscape underwent this massive structural pivot.
Google effectively flipped the switch,
Yeah.
moving from AI that simply talks to you to AI that actually does things.
Totally. So today, we're doing a deep dive into this staggering consolidation in Google's AI ecosystem, published exclusively over these 7 days.
Yeah, there is a lot to cover.
There really is.
Yeah.
We invite you to understand exactly why this specific week redefines how you interact with software, your personal health data, and honestly, the physical infrastructure of the internet.
When you look at the sheer density of announcements clustered around this specific week, it reads less like a list of product updates and more like a comprehensive blueprint
Blueprint for what exactly?
for complete horizontal integration. I mean, the industry is moving from the theoretical physics of how models think all the way down to the physical silicon that powers them.
Right. And the security required to keep them safe in the wild. But, the volume of news is intense.
It really is.
Before we can even deploy autonomous AI into consumer products or, trust it to manage our daily lives, we first have to fundamentally rethink how we even measure its intelligence.
Which is a huge challenge.
It is. And that brings me to a global publication on the Google blog from March 17th. The headline was Measuring Progress Toward AGI, a Cognitive Framework.
Yeah. The DeepMind paper.
Right. So DeepMind published this highly detailed taxonomy inspired by cognitive science to evaluate artificial general intelligence.
And they didn't just publish a paper.
No, they launched a Kaggle hackathon with a $200,000 prize pool to crowdsource new capability benchmarks.
Mitch is super smart.
But I look at this term AGI, and I mean, my immediate reaction is that this is just an industry buzzword.
Sure, it can sound like one.
Like, how do you actually put a hard metric on something as abstract as general human intelligence?
Well, the problem with our current metrics is that they rely on standardized tests.
Mm-hmm.
Like having an AI take the bar exam or the SATs.
Right, the classic benchmarks.
Yeah, but standardized tests are deeply flawed because they primarily measure rote memorization.
Okay, that makes sense.
If a model has ingested the entire internet, of course it can pass a static test. DeepMind's new framework is about testing functional adaptability.
Functional adaptability. So meaning what exactly?
It maps AI performance against the actual distribution of human cognitive abilities.
Yeah.
Like how well can a system learn a totally novel task it has never seen before?
Oh, wow.
Can it recognize its own mistakes and adjust its strategy in real time without human intervention?
So that's why they launched the hackathon.
Exactly. To crowdsource dynamic, constantly shifting edge cases from developers worldwide. Because you just cannot measure true adaptability with a static test.
You need a moving target.
Precisely.
Well, that functional adaptability is exactly what is being put to the test in highly specialized, high-stakes fields right now.
Like scientific research.
Yes, I was looking at a global study published on the Google Research blog just a day earlier, on March 16th.
The superconductivity one.
Yeah, the headline was, Testing LLMs on Superconductivity Research Questions.
Really fascinating study.
Google Research and Cornell University took 6 different large language models and tested them against expert-level physics questions.
But they didn't just ask the questions blindly.
Right. They confined the models to a curated database of 1,726 highly specific scientific sources.
And the results were pretty telling.
They were. The retrieval-grounded system, Notebook-LM, actually outperformed massive general-purpose models like GPT-4o.
Yeah, because the underlying mechanism there is retrieval augmented generation, or RG.
Okay, break that down for us. What does that actually mean?
Well, when you ask a generalist model a complex physics question, it relies on its internal memory. It's essentially trying to predict the next most mathematically probable word based on, the vast, unfiltered internet sludge it was trained on.
Which is basically a recipe for hallucination.
Exactly. But a Raj's system like Notebook-LM changes the architecture completely. It forces the AI to search those 1,726 curated documents first.
So it's like giving it an open book test.
Yes. It pulls the exact relevant paragraphs into its working memory and synthesizes an answer strictly from that controlled sandbox.
So it can't just guess.
Right. It mathematically restricts the AI's ability to guess, proving that tethering a model to ground truth is vastly superior for specialized synthesis than just relying on raw parameter size.
Wow. But when you move from theoretical physics to human biology, the tolerance for hallucination drops to absolute zero.
Oh, without a doubt.
Which brings us to March 17th. Globally, the Google Research blog published Google Research at the Checkup.
A really big day for health tech.
Huge. They unveiled this massive healthcare AI portfolio, including their Amyloid diagnostic agent. But the metric that really stopped me in my tracks was this clinical study on breast cancer detection.
The interval cancer study.
Yes. The AI model successfully detected 25% more interval breast cancers compared to traditional screening methods.
That is a staggering number.
It is, and interval cancers are the ones that develop between routine screenings, right?
Right.
They are notoriously difficult for human eyes to catch.
They are incredibly difficult because human vision and human attention just have biological limits.
Like fatigue?
Fatigue, sure, but also just the physical nature of the scans. When a radiologist is looking at a mammogram, dense breast tissue can easily mask a tumor because both appear white on the scan.
Oh, wow. I didn't know that.
Yeah. Add in visual fatigue after a doctor has reviewed, say, 50 scans in a single shift, and faint anomalies simply get missed.
But the AI doesn't get tired.
No, the AI does not suffer from fatigue. It is analyzing pixel contrast ratios and complex, faint geometric patterns that are essentially mathematically invisible to the human eye.
That's incredible.
Detecting 25% more of these hidden cases proves this technology has finally crossed the threshold from, a theoretical lab experiment to a deployable, life-saving clinical tool.
Having an AI that can synthesize quantum physics and detect hidden visual patterns in medical imaging is just mind-blowing.
It really is.
But a medical lab is a highly controlled environment. If this technology is going to shift into that agentic era we talked about, it needs to understand our personal lives too, not just our medical charts.
Absolutely. It needs context.
Right. And on March 17th, Google announced on their blog that they are bringing the power of personal intelligence to more people in the U.S.
This is a huge shift for consumers.
Yeah, they expanded their opt-in personal intelligence features to all free-tier users across AI mode in Search, the Gemini app, and Chrome.
This rollout really highlights the structural moat of personal data.
Meaning what exactly?
Well, think about it. If you ask a pure-play, standalone AI to plan a family trip, it gives you a generic itinerary based on average internet preferences.
Right, like a standard top 10 list.
Exactly. It is an isolated brain. But by securely connecting a user's data from Gmail, Google Docs, and Google Photos directly into the AI query, Google is turning that isolated brain into an integrated digital proxy.
Oh, I see.
So if you ask Gemini to plan that same trip, it cross-references your flight confirmation in your inbox, checks the hotel booking in your calendar, and references a Google Doc where you listed your dietary restrictions.
That is wildly convenient.
It leverages a unique personal data ecosystem to deliver hyper-tailored assistance. And competitors without that ecosystem structurally cannot replicate it.
It transforms the software from just a search engine into an actual executive assistant.
Completely.
And speaking of changing how we consume information, on March 20th, the Workspace Updates blog announced globally that Notebook LM added cinematic video overviews.
Oh, this update is so cool.
Users can now instantly transform static documents into immersive, Gemini-powered video briefings, plus they added 10 new infographic styles.
We are seeing a fundamental shift in learning bandwidth here.
Learning bandwidth.
Yeah. Humans absorb complex information much faster when it's multimodal, meaning it engages our visual and auditory processing simultaneously.
Right. Nobody wants to just read a wall of text.
Exactly. If you're handed a dense 50-page financial report, the cognitive load of reading and analyzing that asynchronously is massive.
It takes hours.
But by allowing an AI agent to instantly convert that text into a dynamic cinematic video, you are vastly accelerating the speed at which complex information can be consumed, shared, and acted upon across an entire organization.
But giving a consumer a smart assistant or a cinematic video is one thing, right? Giving developers the tools to actually build those autonomous assistants requires a completely different software architecture.
Totally different foundation, yes.
Yeah. You can't just have an AI that chats. You need an AI that can pull up a map, cross-reference a database, and execute a command all at the same time.
Right.
That is why the update on March 17th from the Google Developers blog really caught my eye. The headline was Gemini API Tooling Updates. context circulation, and tool combos.
This is massive for developers.
It said developers can now combine built-in tools like Google Search and Google Maps with their own custom function calls in a single API request.
This is really the invisible engine of the whole agentic shift.
How so?
Well, previously, if an AI needed to check the weather, then check a map, then book a car, it required multiple round trips.
Like back and forth to the server?
Exactly. The AI asks the server for the map, the server sends it back, the AI analyzes it, then it asks the server for the weather. It is incredibly high latency.
This is just slow.
Very slow. But by updating the API, so the model can autonomously circulate its own context across multiple tools in a single unified request, the latency drops dramatically.
Well, that makes total sense.
It removes the friction, making it exponentially easier for a developer to build a complex, geographically aware AI agent that executes real-time tasks without freezing up.
And the tools for actually designing the user interface for these agents are going through a similar paradigm shift, too.
Oh, yeah. Stitch?
Yes. On March 18th, globally, Google Labs introduced Vibe Design with Stitch. It's this AI-native design canvas where users collaborate with an AI agent using natural language to instantly generate high-fidelity UI designs.
It's pretty wild to see in action.
And it introduces a new standard called design.md. It feels like we are moving from being bricklayers to becoming city planners.
That's a great analogy.
You just tell the system the vibe you want, and it lays all the digital bricks for you. But let me ask you, does vibe design mean human UI designers are completely obsolete now?
No, not at all. It just eliminates the tedious friction of pixel pushing.
Some pushing.
Yeah, for decades, UI designers have spent countless hours aligning buttons, adjusting padding, and writing boilerplate code syntax. Stitch just removes that manual labor.
So what does the human do?
It actually elevates the need for human intent and systemic thinking. The AI can instantly generate the interface based on your natural language prompt, but a human still has to decide the strategic flow of the application.
Like where the buttons actually take you.
Right. Where does this interface sit within the broader user journey? What purpose does it serve? The human shifts from writing code syntax to acting as a high-level system architect.
Okay, but you can design the perfect digital city and you can write the most efficient code, but it all still needs to sit on a physical bedrock.
Yes, the actual hardware.
Right. If millions of people are running these hyper-personalized background agents simultaneously, the physical metal powering the cloud infrastructure is going to melt unless there's a radical efficiency upgrade.
Which brings us to the GTC conference.
Exactly, March 16th. The Google Cloud blog previewed their AI infrastructure at the NVIDIA GTC 2026 conference globally.
Huge hardware announcements there.
They committed to supporting the massive upcoming Vera Rubin NVL72 rack-scale systems, but they also previewed fractional G4 virtual machines using NVIDIA vGPU technology.
This is a game changer for startups.
Customers can now rent fractional GPUs in 1/2, 1/4, or 1/8 increments. Now, I have to play devil's advocate here.
Oh, for.
Everyone in tech is obsessed with massive supercomputers. Why is slicing up a piece of hardware into tiny fractions making global headlines?
Because the economics of training an AI and the economics of deploying an AI are completely different.
Oh, so?
So the Vera Rubin NVL72 is a massive rack-scale system where dozens of GPUs act as one giant unified brain. You need that massive scale to train a trillion-parameter model.
Okay, that makes sense.
But inference, which is the act of actually running the model for a user, is a microtask.
Okay.
If you have a small, lightweight AI agent whose only job is to, say, monitor a supply chain database or filter an inbox, giving it a dedicated full-size GPU is like renting a massive semi-truck to deliver a single pizza.
That's a massive waste of capital.
Exactly. Fractional vGPU technology prevents resource hoarding. By allowing developers to slice the compute into eighths, Google is making it economically viable for a company to run thousands of small, specialized AI agents simultaneously.
Without burning through their infrastructure budget.
Right. It drops latency and completely optimizes the unit economics of the cloud.
Okay, but when compute becomes that cheap and millions of autonomous agents start operating across the internet at scale, the surface area for cyber attacks must be expanding exponentially.
Oh, the security implications are terrifying.
Right. We have to move from human monitoring to autonomous defense. So on March 17th, globally, the Google blog announced that SAI 2.0, the Secure AI Framework, launched with new agent security guidance.
SAIF 2.0 is a huge deal.
Alongside it, they released an autonomous open-source defense tool called CodeMender and pledged $12.5 million to the Alpha Omega project.
Yeah, open source defense is critical now.
If we are deploying agents everywhere, human cybersecurity teams literally cannot type fast enough to patch vulnerabilities. Is the idea behind CodeMender that we are entering an era of AI versus AI cyber warfare?
That is exactly the reality we are facing. Look, a zero-day vulnerability can be exploited by an automated malicious script in seconds.
Seconds. Wow.
Yeah, and it takes human threat researchers days to analyze the anomaly and write a patch. CodeMender shifts the paradigm by letting a defending AI autonomously identify anomalous code paths and write the patch before the human team even wakes up.
That is automated defense.
Yes, but SAIF 2.0 goes beyond just patching code. It establishes 3 core non-negotiable principles for agent security.
Okay, what are they?
First, human controllers. Every autonomous agent must have a clear, accountable human owner.
Makes sense.
Second, limited powers. An agent should operate on the principle of least privilege, having only the exact permissions needed for its specific task.
So it can't just go rogue and access everything.
Exactly. And third, observable actions. Everything the agent does must be logged and auditable in real time.
But security isn't just about stopping malicious hackers, right? There is another kind of vulnerability here, and it's the economic foundation of the internet itself.
The publisher problem.
Yes. On March 18th, on the Google UK blog, Google responded to the UK Competition and Markets Authority by proposing new AI opt-out tools for publishers.
This is a really tricky balance.
Websites can now choose to opt out of having their content used in generative AI features, like AI overviews, without losing their standard search rankings.
Right.
Let me push back on how effective this is, though. If every major publisher decides to opt out to protect their copyright, doesn't the AI basically lose its memory?
Yes, eventually.
How does a company balance being a traditional search engine that sends valuable traffic to websites with being an answer engine that synthesizes the information directly for the user?
Honestly, that is the most delicate economic tightrope in the technology sector today.
It seems impossible.
Well, if search engines synthesize everything and send zero traffic to publishers, the economic incentive to create original content vanishes and the open web dries up.
And then the AI has nothing to learn from.
Exactly. The AI would eventually starve from a lack of new training data. But simultaneously, user behavior has shifted. People want instant synthesized answers, not just a list of blue links.
Right. We want the answer right now.
By uncoupling standard search rankings from generative AI opt-outs, Google is attempting to thread the needle.
Giving publishers a choice.
Yeah, they're giving publishers the agency to protect their intellectual property from being synthesized, while assuring them they won't be penalized in traditional search algorithms.
It's an attempt to build sustainable regulatory guardrails.
For the entire digital economy, really, ensuring creators survive the agentic transition.
Okay, you can build the most efficient fractional infrastructure, you can deploy autonomous security patches, and you can establish fair web policies. But none of it matters if the human workforce sitting at the keyboards doesn't fundamentally change how they operate.
That is the hardest part of all of this. Humans.
Right. The final piece of this week's puzzle is human capital. On March 19th, globally, Google published a joint study with Stanford University titled Strategies for AI Adoption at Work.
Really insightful paper.
This 18-month study revealed that successful enterprise AI adoption requires employees to abandon simple substitution and instead adopt a product manager mindset.
We see this productivity paradox every time a major new technology emerges.
What do you mean?
Well, when spreadsheet software like Excel first came out, people initially just used it as a digital calculator to do the exact same math they were doing on paper.
Just a slightly faster calculator.
Right. That is simple substitution. And it yields a neutral return on investment. If you just use an AI agent to write your standard weekly email 3 minutes faster, you haven't transformed your business.
You're just doing the same old thing.
Exactly. The Stanford study proves that massive operational efficiency only happens when workers step back and act like product managers.
So what does that look like in practice?
They have to ask, now that I have an autonomous agent that can process data instantly, how do I completely redesign this entire workflow from the ground up?
Right, to help build that specific mindset, Google, EAA, and Google.org launched a massive upskilling initiative on March 16th called AI Works for Europe.
Yeah, putting real money behind this.
They committed an additional $30 million to the European AI Opportunity Fund, partnering with unions and governments to train 50,000 workers.
Which is a solid start.
Telling an entire workforce to just figure out agentic AI on their own is like taking away their horse, giving them a car, and expecting them to drive it on a dirt trail.
Yeah, you have to actually pave the roads.
But is a $30 million fund realistically enough to pave the technological roads for all of Europe?
Yeah, $30 million will not retrain a continent of hundreds of millions of people.
Right.
The strategy behind that funding is to act as a catalyst. The goal is to fund the creation of highly visible, localized blueprints.
To show it works.
Exactly. When one major union or one regional enterprise successfully redesigns their workflow using this fund, it proves the model works. And we are already seeing this happen in the market.
We are.
Yeah, look at the March 19th announcement from Google Health regarding their partnership with Doc Morris, Europe's leading online pharmacy.
Right. Doc Morris is migrating their infrastructure to Google Cloud to build an AI-driven personal health guide for their 11 million customers.
That is the product manager mindset executed at an enterprise scale.
Because they didn't just add a chatbot.
No. Doc Morris didn't just bolt a basic generative chatbot onto their website to answer frequently asked questions. They are utilizing Gemini to completely redesign the customer journey.
Wow.
They are turning a basic transactional e-commerce event, buying medicine, into a secure end-to-end digital health companion that can dynamically understand symptoms and manage e-prescriptions.
So it's a blueprint.
It is a blueprint. And when competitors see that blueprint succeed, it triggers a domino effect of enterprise adoption across the entire region.
Okay, let's take a breath and zoom out to look at the sheer intensity of what happened between March 15th and March 21st.
It's a lot to take in.
It really is. We saw DeepMind redefine how we measure machine intelligence by testing functional adaptability. We saw retrieval-augmented models outperform generalist AI in quantum physics.
And diagnostic agents catching 25% more hidden breast cancers.
By seeing pixel patterns invisible to humans, we watched personal intelligence roll out to everyday users, transforming search into a hyper-contextual proxy.
While developers got the API updates and the fractional vGPU infrastructure needed to run thousands of these autonomous tools efficiently.
And finally, we saw the regulatory and upskilling frameworks put in place to ensure human workers can safely manage it all.
The common denominator across every single one of these announcements is a definitive shift from passive tools to active agents.
Right.
The era where AI just answers your questions is over. We are officially entering an ecosystem where AI takes complex, multi-step action on your behalf.
And that leaves us with a critical, provocative question for you, the listener, to mull over as you navigate this new technological landscape.
It's something we all need to be thinking about.
If your personal integrated AI agent knows your medical records, your private emails, and your monthly budget, and it begins autonomously interacting across the internet with a retailer's AI agent to negotiate purchases or book your travel. Interacting across the internet to book your travel.
What happens when the machines are primarily talking to the machines?
Exactly. When you are no longer the one executing the tasks, but merely the executive approving the final cut, who is really doing the driving?
That is the defining question of the next decade.
Keep questioning the systems around you. Until next time.